South Africa is a country of extremes with very dry periods as well as times of flooding. Hence, the conservation of not only water quantity but water quality is very important. Rand Water's overriding concern is to supply clean water that is safe to drink, colourless, odour-free and pleasant tasting. It also maintains an extensive source water quality monitoring program, as the consequences of deteriorating raw water have a major impact on both water purification costs and the quality of drinking water. Over 99% of the water abstracted and treated is surface water taken from the Vaal Dam. This surface water is generally of good quality and relatively unpolluted, as it drains from a catchment area which is mainly rural, with agriculture being the main activity. However, along with mining and industrial activities and the problem of an increase in the human population, this is beginning to take its toll on water quality. Rand Water abstracts its raw water from the Vaal Dam via a canal and a gravity pipeline. It also has the option of pumping water from the Vaal River Barrage Reservoir at Letabo, Zekerbosch and Vereeniging. It must now undergo the purification process required to ensure that the water meets the high standards set for drinking water. The process involves 7 stages, which are screening, coagulation, flocculation, sedimentation, carbonation, filtration and disinfection. The conventional purification process removes the suspended material and disinfects the water prior to pumping to the local authorities, the mining industry and other large industrial concerns. Each stage in the purification process is accompanied by changes in the physical and chemical composition of the water. These changes are constantly monitored and corrective action is taken to prevent the water quality from deviating from prescribed limits. When raw water arrives at a purification station, it passes through metal screens. These trap large living organisms, sticks, leaves and litter that allows the water through. All raw water contains suspended particles which need to be removed. The water from the Vaal Dam contains highly dispersed clay particles which tend to remain suspended for a long period. To initiate coagulation, slaked lime is added to the water as the main coagulant to destabilize the electrostatic charges of these suspended particles in the water. A small quantity of activated sodium silicate is also added to the raw water to enable the suspended particles to clump together to form large, heavier clusters, or flocks. This process is known as flocculation. The flock remains in suspension as the water flows at high velocity through the flocculators. Sedimentation is the oldest known method of water purification and has been employed extensively for thousands of years. Although it is a natural phenomenon, it is aided by the addition of chemical coagulants to produce flocks, which are allowed to settle in specially designed tanks, which are also engineered to remove sludge. Rand Water uses horizontal flow tanks with retention times of 4 hours and produces clear water at the outlet weirs. Between 95% and 97% of the suspended particles are removed during sedimentation. Between 500 and 1,300 tons of dry sludge are produced each day during the purification process. This is removed from the sedimentation tanks in a thin slurry. The sludge is pumped to Rand Water sludge disposal site at Panfontein. Here it is dosed with an organic flocculant to aid the separation of the solids from the liquid. The thickened sludge is pumped onto drying beds where it is dried by evaporation, whilst the clear fluid is drawn off and returned to the purification system. The thickened sludge is then spread in 200mm layers over an area of 200 hectares and sun-dried. The use of lime as a coagulant raises the pH of the water to about 10,5, which is very unstable and conducive to scale forming. After sedimentation, the water flows into carbonation bays, where it is stabilized by bubbling carbon dioxide gas through the water. This reduces the pH to between 8 and 8,4, which is necessary to produce chemically stable water that will not cause excessive scaling or corrosion. To get rid of the remaining 3 to 5% of suspended particles, the water then goes through the filtration process. The water passes into the filter houses, where it flows through rapid gravity sand filter beds of finely graded silica sand and pebbles. The remaining suspended particles are removed at this stage. The latest filters constructed have a fine sand layer supported on a gravel layer. They are washed by using the air to first loosen the sand and then water to wash away all the collected dirt. The water leaving the filter houses is disinfected with chlorine to kill harmful microorganisms, bacteria, and any viruses that may be present in the water. Chlorine, however, doesn't remain active for longer than 6 to 8 hours. Disinfection needs to be repeated with chlorine and ammonia at the booster pumping stations so that water is protected right up to the end consumer. Strict guidelines are set for the quality of the drinking water through all stages of the purification process and throughout the distribution system to ensure that the water reaching Rand Water's customers meets the required standards. Rand Water carries out over 250,000 analyses on water samples from rivers, factories and sewage effluents in the catchment area, and over 1.2 million analyses each year on its purification plants and distribution network. The quality standards that have to be met are stringent and based on the World Health Organization standards. Rand Water has one of the most technologically advanced analytical monitoring facilities in the Southern Hemisphere and can conduct tests from tracking inorganic trace elements to acute toxic monitoring. Laboratories are equipped with state-of-the-art equipment. Drinking water is routinely tested for the presence of indicator organisms indicative of pathogens that give rise to waterborne diseases such as typhoid and cholera. Over 500 samples are taken every week from the source water catchment area, the purification plants and the distribution network, and tested for standard plate counts, total and fecal coliforms and E. coli, which may indicate the presence of harmful bacteria. Investigations into the efficiency and effectiveness of current water purification processes and the study of alternative treatment methods is an ongoing activity at Rand Water. Ongoing research develops new techniques of water purification and makes existing methods more cost-effective. After purification, the water is distributed into the Rand Water supply area, which measures some 18,000 square kilometers. It goes through several pumping stations, first at the purification plants and then at the booster stations, and is then stored in reservoirs. As Rand Water is the only bulk water supplier in the world that provides water to a metropolitan centre that is not situated on a large waterway, the organisation has, as a result, become a world leader in large diameter heavy pipe technology, manufacturing pipes strong enough to transport high volumes of water over long distances. Rand Water has the capacity to supply 5,184 million litres per day, although the average daily demand is far less. The water is delivered in bulk from reservoirs to customers, who consist of 4 metropolitan councils, 22 local councils, 1 provincial water supply authority, 2 service councils, 239 mines and about 1,000 small direct customers. These customers are the final link in the chain and in turn supply the drinking water to the general population and businesses. This water is used in houses, businesses and factories for many different purposes. The resultant wastewater which is produced has to be treated at various wastewater treatment works, which are managed by the local authorities before being returned to the natural water cycle. Over the years, Rand Water has become more and more involved in the total water cycle to improve service to the end customers who actually use the water. Besides visibility in national conservation efforts such as National Water Week, Rand Water is also deeply involved in a wide range of educational programs which focus on promoting water conservation. The WaterWise education team offers a wonderful, fun learning experience for learners and educators of nursery schools, schools and tertiary institutions. This service offers edutaining workshops, tours and education material in which a number of hands-on methods are used to impart the WaterWise message and which supports outcomes-based education. The various water topics are brought to life for learners and educators through fun hands-on activities, games, drama, puppet shows, experiments, stories, nature walks, tours, posters, handbooks and brochures. The ultimate goal of this service is for educators and learners to become ambassadors of the WaterWise message and live a WaterWise lifestyle. But what does it mean to be WaterWise? It means to have the utmost respect for water and all life, to use water carefully and not waste it, to not pollute rivers with liquid and solid waste, to pay for water services, to take action to solve any water problem, and to conserve water and thereby conserve the natural environment. Ultimately, Rand Water has a role in changing people's behavior when it comes to water usage. There is a need to make people aware that we live in a water-scarce country and everyone has to contribute towards this. In all its operations, Rand Water strives to support the message that the wise use of water will result in the improvement of our daily lives. By becoming water-wise, we are ensuring that our water supplies can sustain our growing population, our economy, and our natural environment into the future.